Moving on to collapsing data. So what we were just doing was sorting data by, for example, county, and then doing certain things with it. And maybe that is exactly what we want to do. Maybe that's effective. But maybe we actually want to do something else. For example, maybe we care about county level observations, but we don't need to have observations for every store once we've taken into account certain important data about those stores. So we had, for example, when we created this variable right here, the earliest store, we had 4 stores that had 1986 recorded as the earliest store date for County 1003. We could just keep, like by sort county FIPS, keep if underscore little n equals 1, and that would keep one observation within each county, and because they all have this same value recorded, maybe that would be effective. But then, we've had to create this, and then we've had to do a second command. Maybe we actually just want to do something that the collapse command can do. So collapse has a number of options. Maybe you want to type, first break that, maybe you want to type help collapse to see what sorts of things you can do. Here's a list of them. If you are applying weights, we're not going to talk about that right now, but if in the future you do want to apply weights when you use the collapse command, bless you, keep in mind that certain commands can use certain types of weights, but others can't. So we want to collapse sum type 1 and type 2, and then comma by. Now you don't have to include just one unit of observation here. If you had, for example, time variables that you thought were valuable here, maybe by county FIPS open year, you could do that. But we're just going to sum these, collapse it over counties, see what happens. So what happens when we do that? Well, we have now gone to having only 3 variables. We have 1,795 observations rather than the 3176 that we had before. And if we just list, we see that for every county we have exactly 1 observation. Remember, if we had, and when we did type it before, distinct county FIPS, we had a total of 1,795 counties. So now we've got 1 observation for every county, having done this collapse by county FIPS command. And within each county we have summed type 1 and type 2, the type of stores. Remember, type 1 was the number of supercenters, or it was a 1 if type store was a supercenter and 0 if it was a Walmart discount store. Type 2 was a 1 if type store was Walmart discount center and 0 if it was a supercenter. So here we have now summed over counties the number of supercenters and the number of discount stores. You can see how this might be exactly what we want to do if we have some very specific analysis in mind, where we just want to use the number of supercenters in each county. Let's restore, or break that. Let's restore and preserve. Now let's do something more complex here. So let's go collapse. Let's again sum in parentheses type 1, type 2 as we did before. But now let's add more. Now let's do a count. And you can do this with the collapse command. You can tell it to do multiple things with multiple variables. And it will do all of them at the exact same time with the same command. So now we're going to count type store. Then we're going to get the minimum of open year. And let's just, min of open year. And let's get the mean of the store num. This is not going to be a particularly meaningful thing, although it does turn out these data have been used in a way that recognizes there's a very high correlation between the store number and the year of opening. So the mean of store num might give us sort of some general sense of when the average store or like the middle store in the county was opened, or in general like when the stores in the county were opened. And then after we've done that, let's do by county FIPS. Okay, so for some reason it didn't like the count store type or type store. You know what it was? Type store is a string variable. You use your store type 2 variable, which is numeric for that. Apologies for not catching that. Okay, so you should have an extra variable that is here called like store type 2, and it should have the count of the number of stores. But here, let's just list everything that we have. So again, we have 1,795 observations. And we can see that not only did we, like before, get the number of supercenters and the number of Walmart discount stores with the sum over type 2, you should also have with your count the number of total stores. Your count store type 2 should be the total number of stores in each county, so you should be able to sum the number of discount supercenters and the discount stores and supercenters and get that. We also have the earliest year of opening for each year. And, of course, we have this mean of the store numbers. Again, it's not really a meaningful thing. There are plenty of occasions where getting the mean of something would be valuable to you. There just wasn't a variable in these data that I thought would be meaningful. And now we can assert type 1 plus type 2 should equal store type 2, as we said. And if we list everything, we can see that that also works out. Remember, we didn't have many counties for which we had, at least in the first few in Alabama, for which we had both supercenters and discount stores, but where we do have them, we have, for example, in 1051, 1 and 1, and we have a total of 2. All right, let's restore, and you can preserve again if you want these data. Maybe you want to tab open year. You can see there are a lot of different open years. The first open year is 1962. That's the year that Walmart opened its first store. And we have store openings going all the way to 2006, January of 2006 in these data, if you look more closely than open year. We're gonna sort of break down these data right now to show you how you might end up getting some data. Maybe it doesn't come all in one data file. Maybe it's going to come in multiple files, like by decade or something like that. So let's break it down using some of the things that we've learned today. So let's keep if open year is greater than or equal to 2000. And now we're going to use a new type of macro. We're going to say temp file later underscore DTA. What that's saying is we're going to essentially like create this object that we can then save some data file to. This object is a temporary data file. It's not going to be something that we have to save to a particular folder. We're not going to be able to reload it after we close Stata, but we're going to do this. We haven't saved anything to it yet. It's just this this sort of empty object at this point. Now we can save, and in quotations, and then using the same local macro symbols that we learned we needed, we're going to put those in quotations and then the backtick later underscore DTA and that comma replace. And now these data for which open year is only 2000 and onward up to 2006, these data have been saved as later DTA, this temporary data file. So let's restore back to what we had before. We've got every year. And now let's keep if open year is less than 2000. And you can see tab open year. We only have observations through to 1999. So this is a way that you might get some data. You get it in two data files. Now you might actually have two real data files, in which case you wouldn't be calling a temp file. You would actually be doing what we're going to do, appending. You would be appending an actual data file, the second to the first. Here we're just going to append a temporary data file, but it's functionally the same thing. The only difference is if you were appending an actual data file, you'd have to call a file path rather than this local. So we have this data set that's now only covering stores which opened prior to 2000, and we want to append the data file that has all the openings 2000 and beyond. So let's type append using, and then you could type the file path and the file name, or because we're calling this temporary data file, just later DTA called as a local. And now if you tab open year, you see that you've got the entire data file. So this append command essentially takes a set of data and it assumes that you have the same variables. It's not necessary that you have all the exact same variables, but then you'll have a bunch of missings if you have variables in one data set but not the other. When you append them, you'll have missings. But here you're going to essentially stick onto the bottom. If you think of it as a spreadsheet, you stick onto the bottom of the first data set a bunch of new data, new observations, in this case opening years. And then if you have not done so, I want you to save your store openings data in this folder in your directory structure. So save it in your DTA/clean/Walmart folder and save it as store_openings_clean.dta. What I do want you to do, ensure that you have the BEA data installed. Now I think I told you to actually download the .xlsx version of those data. On the same website, there is a .csv version. I want you to figure out how to download through Stata, create a do file that's going to do that. I want you to figure out how to download the .csv data. I want you to make sure that you can import it, import delimited, in the same way that we imported this other stuff. I also want you to double check that you understand how to import the Excel file, so try that command on your own too. And that's going to be your homework for tonight, making sure you have those data and that you can use those commands and creating that do file that downloads that just that CSV file. You can, if you already have a download do file from yesterday, you can just add the BEA CSV data download onto that. If you included the data download in your exercise 4 file, I'd like you to create a new do file that just has the data download as the code and nothing else. And I'd like you to take that out of your exercise 4 do file, which is what we've been working on today. So I want you to have them as separate do files. The reason being you want to be able to organize everything just so. You don't want to have to re-download the data every time you want to use it. You want to be able to run that do file once, download it, and never have to worry about it again unless there's something wrong with the data.